Hey guys, so we're going to learn even more about vectors today. So remember, vectors are sort of discrete line segments that have both direction, and is indicated by the arrowhead, and magnitude, so a distance or a length. So, and then we have the different forms of vectors. There is the where you can have the beginning point and the end point given. There is the component form, which is what we're going to be using today. There's also that IJ form. We're not going to worry about that right now. So today we're learning the dot product. We're going to learn how to tell if two vectors are orthogonal, and we're going to learn if, actually, sorry, I think I spelled that wrong. I think it's orthogonal. And we're going to be able to learn if two vectors are parallel to each other. This orthogonal and parallel would be pertinent in some physics applications, things like that. Computer programming also. Okay, so first, the dot product. The dot product, we know that product means multiply, and you've seen that dot as a multiply sign before as well. So the dot product is a specific type of multiplication that really only applies to vectors. And here it is. If you multiply vector AB times vector AC, you do A times C plus B times D. So first times first, second times second, and then add that result together. This gives you a single number called the dot product. The dot product is a calculation. It's a tool that has applications that we'll be using today and later on this week. So dot product is just one math operation like times, like multiply, that has its own application. Okay, I'm being mobbed by my dogs here, so I hope it doesn't bother you too much. Okay, let's talk about orthogonal. Let me spell it correctly. Orthogonal. Orthogonal basically means the same thing as perpendicular, or two vectors at 90 degrees of each other. So two vectors that form right angles. You could do a little diagram, so a vector going up and down, for example, and then another one going, oops, that's not right. Okay, we'll go with that. So two vectors forming a right angle are perpendicular vectors. In the context of vectors and what we call vector space, the word orthogonal is used rather than perpendicular. Okay, so in order for two vectors to be orthogonal, let's take vector A, B, and C, D. You calculate their dot product, and if the dot product is 0, then those two vectors are perpendicular to each other. So the dot product has something to do with the angle that two vectors make when they cross each other. And a dot product of 0 means that these vectors are orthogonal or perpendicular. Now, right along with perpendicular is the idea of parallel. How can you tell if two vectors are parallel to each other? This actually does not involve the dot product at all, but because parallel kind of goes with perpendicular, they're taught at the same time. So this next part isn't really going to involve the dot product, but the concepts kind of go together. So anyway, to tell if two vectors are parallel, here's what you do. Divide the corresponding terms. So C divided by A, and then D divided by B. And if those equal each other, then those two vectors are parallel. So you actually divide the various components of the vectors, and if they equal each other, you have parallel vectors. Another way to write it is something like this. Vector AB is parallel to vector CD if and only if, there's a fancy math term, and IFF means if and only if. If and only if vector AB equals some sort of a scalar multiple times CD. So where R is a real number. So this is sort of, let me highlight this. This is sort of like a textbook math definition. Textbook math definitions tend to be too wordy, use too much jargon, and are not very applicable to the problems you're supposed to do in homework. So what's applicable to the problems you're going to do in the assignment is this right here. divide C by A and D by B. If you get the same number, then you have parallel vectors. Okay, so there are going to be 10 problems. I'm doing the evens. You'll do the odds, so 5 homework problems or 5 assignment problems. The first group are just dot product. Can you calculate this? So what is U dot V? That's going to be 6 times 4 plus negative 3 times 9. Again, multiply these two together, multiply those two together, and add them. So that's 24 plus negative 27, which is negative 3. The dot product there, negative 3. So number 2, right there. Number 4, what is U dot V? Again, multiply these two numbers, negative 3 times negative 6, plus, and then multiply those two numbers, negative 2 times 4. You can do fancy things with parentheses, maybe, because the negatives get a little confusing. I don't know. Negative 3 times negative 6 is 18, plus negative 2 times negative 4 is negative 8. 18 plus negative 8 is 10. So the dot product of number 4, 10. So it's a very simple calculation. It's just a skill. You're fully capable of learning all sorts of new math skills. It might be hard to remember in 6 weeks what's a dot product, but for now, in the midst of all this, learning and doing a dot product, not difficult. It might not make sense why you do it, but it's a thing. You can do it. As to why you do it, again, you can tell the relationship between vectors potentially using the dot product. So for the next few exercises, we've got 2 vectors that are either going to be parallel, orthogonal, or neither. So you might have the situation where the parallel vectors, you might have right angle vectors, or neither. They might just not cross at right angles or anything. So how do you do this? Well, first is to tell, are they orthogonal? So the first thing you want to do is the dot product. It's what we've been working on. So negative 5 times negative 3, that's these two numbers, plus 15 times negative 1. Okay, that's a horrible looking 5. So this works out to be negative 5 times negative 3 is positive 15, plus 15 times negative 1 is negative 15. That's 0. So as we learned up here, if a dot product equals 0, then these are orthogonal. So the answer to number 6 is orthogonal. And it's very convenient that orthogonal begins with a letter O and we have a 0 here, so they sort of go together. Number 6, orthogonal. Number 8, orthogonal, parallel, or neither. Well, I'm going to pretend like I don't know the answer and do the dot product. So 5 times negative 36 plus 2 times negative 20. So multiply x times x, y times y. 5 times negative 36 is negative 150 plus negative 180. And then 2 times negative 20 is plus negative 40. That's negative 220. So these are not orthogonal. The dot product is negative 220. So now let's see, are they parallel? So to tell if they're parallel, I need to do negative 36 divided by 5 and negative 20 divided by 2. Let me pull up a calculator. I can kind of tell the answer is no, but I'll go through all the motions. So negative 36 divided by 5 is negative 7.2, and 20 divided by 2, negative 20 divided by 2 is negative 10. These clearly do not equal each other, so they're not parallel either. So if they're not orthogonal, not parallel, this one is a neither. Circle answers. So number 8 should say neither, and there it is. Number 10, are these orthogonal? So check U times V first. Oh, wait, what am I doing here? The dot product is 15 times negative 8 plus 40. Oops, that's a funky 0. 40 times 3. 15 times negative 8, negative 120. 40 times 3, 120. Negative 121 plus 120 is 0. So this one should be orthogonal. Let me check number 10, orthogonal. Why do I always spell that wrong? Okay, so I meant to do one orthogonal, one neither, and one parallel, and it appears that I kind of screwed that up. So here, let me just come up here and make one example. I'll do it off the top of my head. Let's say we have vector u is 20, comma 12. Let's say negative 12, and angle v, or I'm sorry, vector v is negative 10, 6. So, what is the dot product? U times v is going to be 20 times negative 10 plus negative 12 times 6. This is negative 200. This is negative 72, negative 272. That does not equal 0, therefore they're not orthogonal. Now let's check and see if they're parallel. Negative 10 divided by 20. So you could probably do this in your head, but I'll go through the motions. That is negative 0.5. And then 6 divided by negative 12. 6 divided by negative 12, negative 0.5. These equal each other. Therefore, in my little made-up example here, they are parallel. Okay, so now you do have an example, orthogonal, neither, and a parallel to look at as you do your 5 assignment problems. So 1 and 3, just find the dot product. The number could be anything. Don't worry about what the number is. 5, 7, and 9, do the dot product. If it's 0, you write orthogonal. If it's not 0, you divide the x's and y's. If the x's and y's divide out to equal each other, it's parallel. And if they do not divide out to equal each other, then you just write neither. Okay, I'll stop there. I'm probably just rambling. Good luck on this. Contact me